Factoring review. The purpose of factoring. So I wanted to go over this because the purpose of factoring is to express it as a product. So we want it to be a product. Factoring means we're changing things to a product. So it should end up being something times something. So product. This allows us to find the roots or solve the equation. So you've heard those words before. Find the roots or solve the equation. So when we look at factored form, right, so when we say something's in factored form, it'll look like this. So we've got 2x times, you can see it's times, that monomial times the binomial, or it can be two binomials. This is not factored form. This is not factored form. This, right? No, it's not. You've got it partially factored. You took an x out of the beginning, but then look, you got this plus 5 sitting here. That's not factored. This part's factored, x and the 2x minus 3. But with the plus 5, it is not in factored form. Does that make sense? So multiplication, this is nothing really. Just really cool. You're really cool as yourself, but also you're not factored form. Okay? So factored form, you're not factored form. Still wonderful, but just no form whatsoever, right? It's not even in completing the square and stuff, which we'll learn this year. We got nothing. So this is what we want, okay? So when I ask you for factored form, I don't mean partially factored. This is partially factored and then an extra 5 sitting there. Does that make sense? So I want it 2 brackets or monomial with brackets. Okay, so one more time. The common factor we always do first step. This is still always our first step. Okay, this will always be our first step. The difference of squares, my suggestion would be to look for 2 terms, right? We're looking for 2 terms with a minus, and they have to be perfect squares. Okay, so if you have 2 terms, there's a minus in between, minus between them, and they're both perfect squares, that would be a difference of squares. Right, so minus between them. Okay, then the next one is factor by grouping. Typically, when we do a factor by grouping, is that we do 2 by 2. 2 by 2, or we're going to learn now this year that it could also be 3 by 1. So this will be new. Okay, so new this year, we're going to do a 3 by 1 as well. Okay, then trinomials. So the factoring methods you have are, of course, you can do the decomp, okay, which is a form of guess and check, right, because you find 2 numbers that multiply to and add 2. Or we call it usually the big X, right, which is also your guess and check, but it's breaking it to 2 smaller groups, right? Guess and check, but keeping it in 2 smaller groups. Up to you. I will never tell you which way you do it. You can do it whichever way you want, as long as you can factor in a timely way, right? If you're taking 10 minutes to factor something and it takes someone else 2, you kind of want to be in that average of, okay, it takes me 5 and it takes you 2. Takes me 5, it takes you 4, right? If there's a big difference between the time it takes you to factor, you got to find a better way or a better strategy for either the decomp or they're both guess and check. You end up with the same numbers, right? So you end up with the same set of numbers, and either way, okay? But you have to be able to factor in a timely way so that you know how to factor. If you keep looking from every number from 1 to 120, 2 to et cetera, and it takes you forever, and then you give up, that's not a good method. Okay, so we have to find a way that works. For example, when you do this trinomial here, and we're going to try to either do decomp or you can break into the 2. I'll do the big X method again just to show you how it is, because most people who do the decomp already know how. So the big X method was that we took the first 2 numbers, and I'll do decomp over here, right? So we'll look at both ways. So big X method was that you take this and you say, okay, this first column goes here. So this first column goes here, and then the second column, the second column goes there. So the 18 can be broken up to 1 and 18, 1 and 18, or 2 and 9, or 3 and 6, right? The 56, we have 1, 56, 2, 28, 3, doesn't work, 4, right? So you can break that up as well. I always start with the left side, right? Let's try to break that up, and you just choose. So it's up to you which way we want to choose. You want to go 9 and 2, 6 and 27 is not huge. I would not start with 18 and 1. 18 and 1 means 18 something times something is going to be really, really big. So something kind of more in between. Anyone have a feeling? It's kind of just a feeling at this point, and then you start. Yep. And try. 3 and 6? Sure. Let's go 3x and 6x. Okay? Then on this side, you know that your choices are, it's 156. I'm never even going to try 156. 56 times anything is huge. So again, not my first goal if the number inside's kind of medium. So 228. Again, 28 times anything, it's kind of big. 3, does 3 go in? No. 4 and 14? 4, 14, and what else? Anything else? What multiplies to 56? 7 and 8. And then you kind of cycling back, and we get nothing else, right? So 6 doesn't work, 5, and then you cycle back around. So then you have 56. 56 is an even number, so it can't be with the 6. I already said I'm not going to try that one right now, right? It's too big of a number. 56 times 8. Same with 28. 3 times 20. Yeah, I'm not even going to look at that. I'll come back to it if I need to. Okay, so let's try 4, 14, or 7 and 8. 4 and 14 are both even numbers. So they can't be besides 6, because your first step on this is always to look for common. If there's no common number between 18, 27, and 56, I can't put an 8 here because that means there's a common 2. So remember, your bracket is written like this. So if I put the 8 here, that means there's a common factor in my binomial of 2, and there isn't. So I can't put the 8 there. So the only place I can put it, so 4 and 14 will not work. I can't even try 4 and 14 because it's beside a 6. Either way, the 4 and 14, so I already eliminate. So that's why. So there's more of an elimination method. So 7, 8. I can't put the 8 there. I can put the 8 here and 7. Then you crisscross. So 3 times 7 is 21. 6 times 8 is 48. Is there any way that those two can make 27? Yes. If it's positive 27, the bigger number stays positive, and the smaller number is negative because it adds to positive 27. So if this is 48, you go to the 48 line. 6 times 8 is positive 48, so I put plus. 3 times 7 is negative 21, so I do negative. Okay, so then we've got those two numbers. These are my two brackets. So this here is, I'm just going to answer it over here. Sorry. Shouldn't have put the line up there. And then my answer for this one would be 3x plus 8 times 6x minus 7. And you check again. Those two do multiply to negative 56. We're good to go. Okay? Decomp, if you do decomp, you're looking for 18 times 56 and two numbers that multiply to 1,008 and add to 27. No. No, because it's basically you have to start at 1,008, go 1 to 1,008, no, 2 to 504, no, 3. Honestly, when I was looking at my grade 12 tests, most people are doing this guess and check. Most people are not doing decomp anymore. You start to kind of get fed up with it because it's such a big number, and then this usually feels better. Again, I've had 1 or 2 students who are like, they can decomp fast, though. They're like, boom, 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 boom. They do 2 by 2, and they're good to go. That's totally fine. If you're good, that's good. I just need you to know a method that works. Do you know what happens with the 1,008? You end up finding these same two numbers. That's what I said. You have to go until you get to 21 times 48 is 1,008. 21. And I'm like, that's 1,008. So decomp is you're looking for the same two numbers that I find, but I keep the numbers smaller, right? So I'm looking for two numbers that multiply here and here. So I find this a little bit, sorry, allergies, a little bit better. But either way, but when you're doing the decomp, you're looking for two numbers that multiply to that, to 1,008. Do you know the two numbers you find are the same two numbers we found here? That's why I said they're both guess and check. It's just they keep them in separate kind of boxes. Okay, so if you found your 21 and 48, then you're going to go your 2 by 2 bracket, and then you're going to do your common factor. Do you want me to show you decomp again, or you're okay? People who know decomp are usually, they just need the two numbers. Your two numbers are these, 21 and 48. And you go 2 by 2, the grouping method. All right? Right, so that's okay. So I'll skip on to the next one. All right. So if you have a number, if you have a number in front with no variable other than a coefficient of 1, so if this coefficient is 1, all you have to do is look for the two numbers that multiply. So even if you're doing the x, which is not useful, it's just x and x. The next here, you're looking for two numbers that multiply to 75, which is 15 and 5. And guess what? It's 15 and 5 is 20, and those are your two brackets. So this method works. It's just that you don't need to put it on the x, because it's x and x. If it helps you focus it, then that's fine, right? Okay, so if you want, it's just you don't need to because the x's are here, right? It's just a single x, so that's why. So you're looking for two numbers that multiply to the 75 and add to the 20, and I found it was 15 and 5. Okay, and again, this stuff here is done on the side. This is done on the rough or on the side, so this whole part here, this wouldn't have been part of my solution. You can do that on the rough, and then just give me your answer. Okay, so for over there, up to you. Okay, I don't need to see the steps there. All right. So you can do it on the side. Some people just do it in the corner of the page. Sometimes we give you room on the page and say rough work over here, that sort of thing. So here, changing the exponents now. So it's still the same thing. As long as this is half, that's a 4, and that's a 2, and that's half. If it's half the number, then you can still do the same factoring. So it's x squared times x squared. Right? And then if it's half of it, then you know that the middle term would be the x squared. If that was a 3, that wouldn't work. Right? If that was a 4 and a 3, then it's not a trinomial. But for a trinomial, it's half the number of exponents because you break it into the half and then it adds to be that middle term there. So you're looking for two numbers that multiply to positive 9 and add to negative 6. And I don't care about the first one because the first coefficient, there's no number, right? So it's negative 3 and negative 3 I'm seeing, like that. When you get the same two brackets, we said that we do want you to do this. Okay, we do want you to make it squared. Okay, we do want you to clean that up, please. Okay, and we started that last year a little bit. We always want you to clean it up. Okay, it's not wrong, but we'll lose communication marks on that. All right. Then we said, what happens if we have variables on both sides? So same thing, if you're thinking about it this way, I have an x and a y times a y, right? In the middle, look, x times y and x times y is xy, so it meets in the middle, right? So both of them are middle. Same thing here, you can do x squared on the left side. You don't have to do this, right? But we know it multiplies to positive 6, so or negative 6, and adds to 5. So that's going to be 6 and 1 or 3 and 2. Both of them add to 5, though. So which one is it? 6 and 1 or 3 and 2? 6 and 1 or 3 and 2? 6 and 1, because 3 and 2 would need to be the same sign to get to positive 5. It'd have to be positive. So negative 6 and a positive 1. Okay, and again, you don't have to do it on this because it's supposed to be, quote unquote, the simple type of quadratics. Yep.
Wouldn't it be a...
Oh, sorry, other way. Thank you. Yes, thank you. There you go. Right, so then positive 6, negative 1. And then again, you don't have to do that for the simple ones. You just go x plus 6y and then x minus 1y, like that. Okay, it's not wrong if you do that. Like on the rough paper, I'm not going to be marking it going, oh no, why'd you do that? Some people are like, oh no, I started doing it for the simple ones because I got so used to doing it. Right, so even with the 1. This one is actually a simple type with the 1 in front, but you have to always remember common, right? Common first. So the common factor should come out first, and you should get out the -2. So definitely always remember the common factor. We're going to get x squared minus 14x and then plus 49. Okay, then it's just a simple, you keep the -2 in front, right? So we kept the -2 in front here. And then you're looking for multiplies to positive 49, adds to -14. It's only 7 and 7. And they both have to be the same. And then I want to finish that. You could skip right to this answer if you're like, oh, I can see there's 2. If you see there's 2, you can go right to that answer and square. All right. Any questions? Clarification? Okay, next page.